Hello, my dear students. I'm SD Sir from EDUINFINITE Calcutta. Today, I will cover up some basic concept and the application. That is the concept of mole and its application, which is a very, very important part. Even a simple problem comes to be a critical one without having the proper knowledge of mole. Now, I'm not going to discuss the definition of mole. You know everything which is in the textbook. My question is, how can we find out the number of moles? Moles is nothing but a number equivalent to Avogadro's number. Case 1, if number of atoms or molecules or ions be given, then number of moles is equal to given number of atoms, molecules or ions divided by Avogadro number. You know the value of Avogadro number. This is case 1. If case 2, if amount of a substance be given, substance means chemical compound or element, then first what to do? Convert the given mass in gram. That is the first step. Any unit given with respect to the mass of the substance, you should have to convert it into gram. Then number of moles is equal to given mass in gram divided by molar mass of the substance. So case 1 is when the number of any particle is given, it may be electron, proton, atoms, molecules, and whatever it is related to the chemistry. Mention that number and divide by Avogadro's number to get the value of number of moles. Case 2, when the amount of a substance be given, then your first choice to convert the mass into gram and then to get the number of moles in given mass of the substance in gram by molar mass. Case 3, another one, whenever the volume of a gas is mentioned at STP, when the volume of a gas is mentioned at STP, volume of gas is given maybe at any temperature and pressure, your first step, convert the volume in liter. Now 1 liter means 1 decimeter cube, the same thing at STP. If the volume already is given at STP, no need to change, only you have to change the given volume in terms of liter or decimeter cube. But if it is not given at STP but at any other temperature and pressure, apply this equation P1 V1 by T1 is equal to P2 V2 by T2. Here P2 V2 and T2 are at atmospheric pressure 1, absolute zero temperature, that is 273 Kelvin. Under that you will get the value of V2, that is the volume at STP. So calculate that. After that what to do? Then number of moles will be volume of gas in liter or decimeter cube at STP, what you have already deduced, divided by 22.4, divided by 22.4. So these are the three steps or three cases by which we can find out the number of moles. Let us apply this concept to calculate the number of moles in different cases. Case 1. Calculate the number of moles present in 3.01 into 10 to the power 20 molecules of CO2. 3.01 into 10 to the power 20 molecules of CO2. In this case, what is the number of moles of gas, oxygen, carbon dioxide present? What to do? As I have mentioned, that when the number is given, to calculate the number of moles, take the number of molecules or particles given divided by Avogadro's number. You will get the value. You will get the value and it will be 0.5 into 10 to the power minus 3 mole or 5 into 10 to the power minus 4 mole. This is the first case. Second case, when mass of a gas is given, suppose calculate the number of moles present in 220 milligram of CO2 gas. Calculate the number of moles of CO2 present in 220 milligram. As I have mentioned you, whatever is the unit given, convert this mass to 20 milligram means is equivalent to 220 into 10 to the power minus 3 gram. That should be the first step. Convert the mass in gram. Then number of moles is equal to 220 into 10 to the power minus 3 over molecular mass of CO2. Molecular mass of CO2, we know it is 12 for carbon and 2 into 16 means 32 for oxygen, making 44. So divide it by 44 and answer will be how much? Answer will be 5 into 10 to the power minus 3. 5 into 10 to the power minus 3 mole. This is the application of the second case. Third case, when the volume of a gas is given, how can we apply it there? Suppose the question is 896 milliliter of hydrogen gas at STP is given. 896 milliliter of hydrogen gas at STP is given. You have to find out the number of moles present. As I told you, this 896 ml comes to be 896 multiplied divided by 1000 means 10 to the power minus 3. This much liter or decimeter cube. So first convert the volume into liter and the condition must be at STP, otherwise you have to calculate at STP. After that, number of moles is equal to given volume in liter divided by 22.4. That will give you the number of moles and which comes to be 40 into 10 to the power minus 3. 40 into 10 to the power minus 3 means 4 into 10 to the power minus 2 mole. So these are the methods to calculate number of moles. Okay, so you can apply by this way whatever it is given, either number of particles then divide by Avogadro's number, or the mass of the substance convert in gram then divide by its molar mass, or volume of a gas, given amount of gas, volume of a gas at STP, then divide that volume in terms of liter by 22.4 to get the number of moles. So that's all for our first discussion. In near future, definitely I will discuss some more tricks, and this will help you a lot in calculating the numericals, because these are the simple steps you must have to swallow, or you must have to know, otherwise it's difficult to crack competitive exam. So thank you very much, my students. Hoping the discussion is you have learned it very well, understood very well, and follow our next slide in future. Thank you.